This is Pre-Calculus Section 1.4 Notes, Day 3. We certainly saved the best for last today when it comes to rational expressions. Today we are going to be talking about compound fractions. A compound fraction is a fraction in which the numerator, the denominator, or when they're really fun, both are fractional expressions. So we need to tie all the tools in our toolbox together today for this lesson. Now, there are two ways that I'm going to teach you to simplify a compound fraction. Option one is that you can kind of simplify it in pieces. You can create one fraction in your numerator, so you work on the numerator first. You create one fraction in your denominator, and then after doing this, you would multiply the numerator by the reciprocal of the denominator. So this is essentially simplify numerator and denominator, then keep, switch, flip. Okay, that's what option one is. Option two, which is my preference because I think most of the time it's a little bit faster, and I also call this the LCD method. Option two is you can multiply the numerator and the denominator of the compound fraction by the LCD of the fractions in the compound fraction. And again, I'm going to show you both ways with the same problem so that you can see the difference, and maybe you'll have a preference as well. I don't care when you work on these problems in your homework. It doesn't matter to me which option you use. Please pick one that you're comfortable with and work with that, because it's just better to practice the same way all the time. It's nice to know both, but I want you to be solid on at least one of these methods. Okay, so let's take a look at problem number one. All right, we're going to do it both ways. We're going to start with option one. So option one is the keep, switch, flip. Well, before we can keep, switch, flip, our first job is we need to make one fraction in the numerator and we need to make one fraction in the denominator. So when I look at my numerator, I've got two fractions here that I need to add together. This is over a 1, right? So I need a common denominator for q and 1, which I think q would be an awesome choice, right? So I'm going to make two new fractions that both have q in the denominator. So now I look at my old denominator and my new denominator, and I figure out what I need to do to make my new numerators, just like we were practicing in yesterday's lesson. My first denominator is q. I didn't change it, so I'm not going to change my w. That is going to stay the same. My second denominator was a 1, and I made it into a q, which means I multiplied it by q. So then I have to multiply the 2 by q as well. That's going to give me 2q. So when I add these together, now that I have a common denominator, my numerator becomes w plus 2q, that's a family, over q. Now I have to do the same thing with the two fractions that are in my denominator. So again, I need a common denominator for 1 and w. I'm going to say w. I'm going to chop slash that right there. Okay, so I changed the 1 into w, so I'm going to have to multiply the 2 times w, so that's going to be 2w. And then w stayed the same, so that negative q is going to stay the same. So here on the top, I'm going to have 2w plus negative q as a family over w. All right, so now I'm going to keep, switch, flip. Okay, so the top fraction is what we keep. That's going to stay the same. So we're going to have w plus 2q family over q. We're going to switch from division to multiplication, and then the bottom fraction gets flipped. So the w will be upstairs, and the 2w, and we can just put minus q, goes downstairs. Okay. we're almost done. Now we just need to combine our numerators and our denominators with multiplication. So essentially that's just going to be writing this stuff next to each other in one fraction. So our numerator is going to be w times w plus 2q. Our denominator is going to be q times 2w minus q. We don't have anything here that we get to cancel out. So this is our final answer. Okay, that was option 1. Again, we made one fraction in the numerator. We made one fraction in the denominator. So we kind of did a step 1, a step 2, and then we did a step 3. So I'll label this was our step 1, this was our step 2, and this was our step 3. Okay, option 2, we need to figure out what is our least common denominator. So we have to look at all 4 denominators in this expression. So again, I'm going to put those 1s back under there so we can look at all of our denominators. So it looks like we've got a q and a 1 and a 1 and a w. So our LCD here would be q times w. So this is where it gets a little bit messy. This is why I've got the super fine pen going on here. I am going to multiply everything by my LCD. Okay, all 4 fractions are going to get multiplied by QW in the numerator. So QW, 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 QW. Okay, and now I'm going to do some reducing, right? Because if something is the same upstairs and downstairs, you get to cross it out. So I can cancel that q with that q, and I end up with w times w, which is w squared, plus 2qw. Okay, that's my numerator right now. Downstairs, I'm going to have 2 times q times w, so that's going to be 2qw minus, here I get to cancel my w, so I have q times q, which is q squared. Okay. Now, the only thing left to do is I can do a little factoring in my numerator and I can do a little factoring in my denominator. In my numerator, I have a GCF of w. So if I factor that out, then I have w plus 2q. And in my denominator, I have a GCF of q. So if I factor that out, I have 2w minus q. So as you can see, I ended up with the exact same answer as option 1, but I think option 2 usually tends to be a little bit quicker. And again, that was the LCD method. All right, so let's try the next example, example number 2. Okay, so I'm going to do this one using option 2. So I'm looking for what is the LCD for this expression. So I need to look at all of my denominators at the same time to determine this. All right, well, this denominator is m plus n. This denominator is m. And this denominator is a 1. So my LCD, I'm going to write it up here. My LCD is going to be m plus n, that family, times m. So m times m plus n. That is what I have to multiply every numerator by. So this is going to get a little bit crowded, but as long as I know what I'm doing, I should be able to keep it straight. All right, so m times m plus n, m times m plus n, m times m plus n. Okay, so in my first expression, my m plus n's are going to cancel. So what I have left is just 1 times m, which is m. In my second expression here in my numerator, the m's cancel. Now be careful, that negative sign belongs to the 1. So it's going to be m minus 1 times m plus n. And then downstairs, nothing's going to cancel, right? Because my denominator is a 1, so I don't get to cross anything out in my denominator. So I'm just going to have n times quantity m plus n. I'm going to go alphabetical. So m, n, m plus n. Okay? Now, don't get too excited here and think, oh, I can cross out those m plus n's. You can't do that yet because we still have to simplify our numerator first. we have to distribute this -1 and combine like terms, if we have any, before we can do any canceling. You must always completely simplify your numerator before you try to cancel. So we have m, and then -1 times m is going to give me -m, and -1 times n is going to give me -n. And then on the bottom, I can leave that in factored form. So mn times m plus n. Okay, so my m's are going to cancel out. That's going to leave me with -n in my numerator, and then m times n times m plus n in my denominator. Now, there is one more thing I can do here, okay? I can also simplify those n's. So I can go ahead and cross that out as well, but keep in mind there's still that negative sign up there. So my final answer is going to be a -1 over m times m plus n. And that is going to be my final answer. For our last example here, we're actually going to change it up. Rather than do example number 3, I want you to take a second here, and I want you to copy down this problem. This is going to be problem number 53, straight off your homework assignment. So I'm going to give you a little bit of a bonus head start here. 1 plus 1 over c minus 1. That's my numerator. And 1 plus -1 over c minus 1. That is my denominator. Okay? So this is the complex fraction that we are going to simplify. And again, I'm going to use option 2, okay? But you could certainly use, actually, you know what? I take that back. I'm going to use option 1. I did option 2 on the last one. I'm going to do option 1 on this one just so you can see option 1 being done again. So if I want to make a common denominator here, because that would be my first step, is to simplify my numerator, then I need to look at the fact that I've got really 1 over 1 here. My common denominator for my numerator is going to be c minus 1 and c minus 1. Okay, so my second denominator didn't change, therefore my numerator is not going to change. But my first denominator, I changed to c minus 1, so I have to multiply 1 times c minus 1, so that's going to give me a c minus 1 right there. Okay, I'm going to do the same thing in my denominator. Here I've really got 1 over 1, so my common denominator is going to be c minus 1 for both. This is going to stay -1. C minus 1 is what I change my denominator to, so c minus 1 is what I have to change my numerator to. Okay, so now I can go ahead and I can add each of these fractions together. So in my numerator, my common denominator is going to be c minus 1, and it's going to be c minus 1 plus 1. And in my denominator, it's going to be c minus 1 minus 1 over c minus 1. So those are going to cancel, and I'm just going to have c over c minus 1. Minus 1 minus 1 is minus 2, so this is going to be c minus 2 over c minus 1. And then my last step here is going to be the keep, switch, flip move. So my top fraction I'm going to keep, c over c minus 1. I'm going to switch my sign to times, and my bottom fraction I'm going to flip. So c minus 1 goes on the top, c minus 2 goes on the bottom, and now you can see that my c minus 1s are going to cancel out, and my final answer is going to be c over c minus 2. Okay, that was option 1. Now let's just pause for a moment and take a look at what this would look like using option 2. If I'm going to do option 2, starting back at the beginning here, my LCD is going to be c minus 1 because, again, I have to look at all my denominators. I've got a 1, a c minus 1, a 1, and a c minus 1. Now I'm going to multiply every numerator by that LCD. And I'm going to cross out what I can. So that's going to cancel that. That's going to cancel that. So my numerator becomes 1 times c minus 1, which is c minus 1 plus 1. And my denominator is going to be 1 times c minus 1 minus 1. So I end up with c over c minus 2. That's why I like option 2.